Hello everyone, a warm welcome to the next session of Deep Learning with Keras. I hope you understand all the concept that we have seen in the previous session. Yeah, that is Introduction to Deep Learning and Keras. So I hope you understand introduction part of deep learning, what is an artificial neural network, introduction of Keras, yeah, about the theory of Keras, the features of Keras, the benefit of Keras, why to use the Keras, yeah, and the installation of Keras. What are the steps we need to perform in order to install Keras in our system successfully? Yeah. So remember, in a previous session, I have shown you how you can install Keras in our system in the machine successfully by performing some steps. Yeah. So now let's proceed to the next session, today's session. Yeah. So in this session, you will learn Keras models, layers, and modules. Okay, so in the previous session, you have just installed the Keras successfully in your system, yeah, by performing some steps. Am I right? You remember it? Yeah, so I have shown you practically how you can install the Keras in your system, right? So in the previous session, we have installed the Keras. Now it's time for us to learn the Keras models, okay? And what are the layers of Keras, and then the modules. What are the Keras modules, okay? So let's start with the first point, okay? So let me show you what you are going to learn exactly in this session. Okay, so see, the first thing, as I told you, you are going to learn the Keras models. So under the Keras models, you will first of all understand the sequential model. Okay, and then functional API. Okay, so these points you are going to study, you are going to learn, you are going to understand under the Keras models. Okay, and then you will learn the Keras layers. Okay, under the Keras layer, you will understand the dense layer, dropout layer, convolution layer, and pooling layer. And finally, you will understand, you will learn Keras modules. Okay, so let's start with the first point, Keras models. Okay, so see, Keras provides a complete framework to create any type of neural networks. Keras is innovative as well as very easy to learn. It supports simple neural network to a very large and complex neural network model. Okay. In Keras, every artificial neural network is represented by the Keras models. In turn, every Keras model is a composition of Keras layers and represents artificial neural network layers like the input layer, hidden layer, output layer, convolution layer, pooling layer, etc. Yeah, are you getting the point? Yeah. So Keras provide a complete framework for us to create any type of neural network. Keras is an innovative as well as very easy to learn. And it also supports simple neural network to a very large and complex neural network model. Okay, so in Keras, every artificial neural network is represented by the Keras model. In turn, every Keras model is a composition of Keras layer and represent artificial neural network layers such as the input layer, hidden layer, output layer, convolution layer, pooling layer, etc. Okay, Keras model and layer access Keras modules for activation function, loss function, regularization function, etc. Using Keras model, Keras layer, and Keras modules, any artificial neural network algorithm such as convolution neural network, recurrent neural network, etc. can be represented in a simple and efficient manner. Okay, so Keras model and layers access the Keras modules for the activation function, loss function, regularization function, etc. Using Keras model, Keras layer, and Keras modules, any artificial neural network algorithm can be represented in a simple and efficient manner. So there are different ways to create the Keras models. So mainly you can say three ways that I'm going to show you. Yeah. So see, there are some ways, there are different ways to create the Keras model. So the first one is the sequential model. The sequential model, which is very straightforward, a simple list of layer, but limited to a single input, single output stacks of layer, as the name given gives away. Okay. Now next thing is the functional API, which is an easy to use, fully featured API that supports arbitrary model architecture. For most people and most use cases, this is what you should be using. This is the Keras industry strength model. Okay, and the third one is model subclassing, where you implement everything from scratch on your own. Okay, use this if you have the complex out of the box research use cases. Okay, so you can see here there are different ways to create Keras model. So three ways to create the Keras model. First one is the sequential model. The second one is the functional API, and the third one is model subclassing. Okay, out of this, we are going to focus on the most important sequential model and functional API. Okay, so let's see that sequential model. Okay, so see, sequential model is basically a linear composition of Keras layers. Sequential model is easy, minimal, as well as has the ability to represent nearly all available neural networks. It allows us to create the models layer by layer in sequential order. Okay, it allows us to create models layer by layer in a sequential order, but it does not allow us to create the model that have multiple inputs or output. Are you getting the point? Okay. So sequential model is basically a linear composition of Keras layers. Sequential model is easy, minimal, as well as has the ability to represent nearly all the available neural networks. It allows us to create the models layer by layer in a sequential order, but it does not allow us to create the models that have multiple inputs or outputs. Okay, got the point? The sequential model is very simple to use. However, it is limited in its topology. The limitation comes from the fact that you are not able to configure the model with shared layers or have the multiple inputs or outputs. Sequential Model API is a way of creating deep learning models where an instance of the sequential class is created and the model layers are created and added to it. Got the point? Yeah. Okay. The core idea of sequential API is simply arranging the Keras layers in a sequential order, and so it is called the sequential API. Okay. The core idea of a sequential API is simply arranging the Keras layers in a sequential order, and so it is called sequential API. Most of the artificial neural network also has layers in a sequential order, and the data flows from one layer to another layer in a given order until the data finally reaches the output layer. Yeah, are you getting the point? Yeah. So an artificial neural network model can be created by simply calling the sequential API as specified below. So how you can create it? It's very easy. You just need to write from keras.models import sequential. Okay. And then model is equal to sequential. Can you see this one? Yeah, that I highlighted here. Okay. So before going to deep, before going to cover the more thing about the coding part of sequential model, I hope you understand the sequential model, the theory we have seen till now. So see, there are three ways you can say to create the Keras model. The first one is the sequential model, which is very straightforward. Okay, a simple list of layers. Okay. Now next is the functional API, which is an easy to use, fully featured API that support arbitrary model architecture, and then model subclassing, where you implement everything from scratch on your own. Okay, so we started with the sequential model. So sequential model is basically a linear composition of Keras layers. Sequential model is easy, minimal, as well as has the ability to represent nearly all available neural networks. Okay. The sequential model is very simple to use. However, it is limited in its topology. The limitation comes from the fact that you are not able to configure the model with the shared layers or have the multiple inputs or outputs. The sequential model API is a way of creating the deep learning models where an instance of the sequential class is created and the model layer are created and added to it. Okay. The core idea of sequential API is simply arranging the Keras layers in a sequential order, and so it is called sequential API. Most of the artificial neural network also has the layers in a sequential order, and the data flows from one layer to another layer in the given order until the data finally reaches the output layer. Okay, so an artificial neural network model can be created by simply calling the sequential API as specified below. Okay, so just need to write these two lines. Can you see this one that I highlighted in a red color? From keras.models import sequential, and then model is equal to sequential. Okay. Now next thing is our neural network model will consist of a linear stack of layers. Okay, to define such a model, we call the sequential function. So model is equal to sequential. Okay, so the first thing is you need to import the sequential from keras.model. So the first line you should write from keras.models import sequential. Okay, what we are learning the sequential model. Okay, so from keras.models import sequential. Okay, so that we can build the sequential model. So the first line should be from keras.models import sequential. As our neural network model will consist of a linear stack of layers. Okay, so to define such a model, we need to call the sequential function. So model is equal to sequential function. Can you see this one? Model is equal to sequential. Okay. Now next we need to add the layers. Okay. So the first thing is to import sequential, yeah, from keras.model. So right, from keras.model import sequential. Okay. And the next thing is our neural network model consists of a linear stack of layer. So to define such a model, we need to call the sequential function. So right, model is equal to sequential. And then next thing we need to do, we need to add the layers. Okay. So before going to explain you how you can add the layers, let's first of all execute these two code. Which one? From keras.models import sequential, and then model is equal to sequential. Okay. So let me open the Jupyter notebook. Yesterday I have shown you how you can open the Jupyter notebook. So here I have already opened the Jupyter notebook. So you just need to copy this, yeah, and paste it in your browser. So I have already done so. So see here. So first of all, need to install the Keras. So I hope you know how you can install the Keras. Yeah. So let me run it again in front of you. So by the way, it's already installed in my system. Okay. Now next thing is from keras.models import sequential, and then model is equal to sequential function, this one. Okay, so let me run the code in front of you. So see, it's running. Okay, both are running. So just wait for it. Okay. So our neural network consists of a linear stack of layers. So in order to define such a model, we need to call the functional sequential. What function we need to call? We need to call the function sequential. So right, model is equal to sequential. Okay. So see, it's running. Okay. So let it run. Now let's proceed to the next theory part. Next, once you import the sequential from keras.model like this one, From Keras.models, import sequential, and then model is equal to sequential. After that, we need to add the layers. Okay. We will be defining our deep learning neural network using Keras packages. So we import the sequential, dense, dropout, and activation packages for defining the network architecture from, okay. What we need to do next? We need to add the layers. Okay. So we will be defining our deep learning neural network using the Keras packages. So for that, we need to import the sequential, dense, dropout, and activation packages for defining the network architecture. Okay. So you need to import all these packages. Which one? Sequential, dense, dropout, and activation. So right from keras.layers, import dense, activation, dropout. So you might think, what is dense, what is activation, what is dropout? So don't worry. In this session only, I'm going to explain all these things. Okay. So, but as of now, in order to add the layers, the first thing is we need to import the packages for defining the network architecture. Okay, so what packages we need to import? We need to import dense, dropout, activation, and the sequential. So we have already imported the sequential. So now just add from keras.layers import dense, activation, dropout. Okay. So now let's execute this command also. So it's still running, so no problem. So see the third one from keras.layers import dense, activation, dropout. Let me run this code again. So it's running, don't worry. Okay, so what we have done, the first of all we have imported the sequential from keras.models. Yeah, so from keras.models import the sequential. Okay, so our neural network model consists of a linear stack of layers. So in order to define such a model, we need to call the sequential function. So right, model is equal to sequential. After that, we need to add the layers. Okay, so we will be defining our deep learning neural network using the Keras packages. So for that, we need to import the packages such as dense, dropout, and activation packages for defining the network architecture. So write the code like this one from keras.layers import dense, activation, dropout. Okay. Now let's see the next thing. You might think, what is this? So don't worry, I will explain you that also. Now see, each Keras layers in the Keras model represent the corresponding layer, input layer, hidden layer, and output layer in the actual proposed neural network model. Okay. Keras provides a lot of pre-built layers so that any complex neural network can be easily created. Okay. So to add a layer, simply create a layer using the Keras layer API and then pass the layer through the add function. Okay, so let's see how to add the input layer. Okay, so before going to add the layer, so you need to make sure that you have imported the packages such as dense, dropout, and activation from keras.layers. So write this code from keras.layers import dense, activation, and dropout. Okay, after that, see, each Keras layers in the Keras model represent the corresponding layer such as the input layer, hidden layer, and the output layer in the actual proposed neural network model. Okay, Keras provides a lot of pre-built layer so that any complex neural network can be easily created. So to add a layer, simply create a layer using Keras layer API and then pass the layer through add function. Okay, so let's see how to add the input layer. Okay, so let me show you that. So see, the first thing we need to add the input layer. Okay, so we define the input layer, which is the first layer in our network using the following program statement. Okay, so what is the statement here? Model.add dense. Okay, can you see this one? Model.add function inside that dense of 512, comma, input underscore shape is equal to, can you see this one? 784, comma, and then closing the parenthesis. Yeah. So what is this statement? So actually, this is going to create a layer with 512 nodes, neurons, with 784 input nodes. So this is depicted in the figure below. Let me show you that. So see here, the input vector 784 pixel, and can you see the layer 1 with 512 nodes. Okay, so what we are doing here, we are adding the layers, okay, into the models. So the first layer we are adding here is input layer. So we define the input layer, which is the first layer in our network, using the following program statement. So you can see this statement that I highlighted in a red color, model.add function, and then inside that dense of 512 comma input underscore shape is equal to 74. Okay, can you see this one? So what is this statement? So this statement is going to create a layer with 512 nodes, neurons, with 784 input nodes. So this is depicted in the figure below. So 512 nodes, 784 input. Okay, can you see this one? The layer 1 input layer with 512 nodes, and then the input vector with 784 pixel. Can you see this one? Yeah, because we are specifying input shape is equal to 784. Can you see this one? Okay, so this is going to create a layer with 512 nodes or neurons with the 784 input node, with 784 input node. Can you see this one? Yeah. So next, let me show you what is the next thing. So see, in this statement, model.add dense 512 comma input underscore shape is equal to 784. Here, what is this dense? Okay, so see here, dense is an entry level layer provided by the Keras, which accept the number of neurons or units. So in our case, it is 512 neurons as it required parameter. Okay, so dense is a entry level layer provided by the Keras, which accept the number of neurons or units as its required parameter. Okay, so if the layer is the first layer, then we need to provide input shape also. Okay, so since this is our first layer, input layer, so if the layer is the first layer, then we need to provide input underscore shape. Can you see this one? We need to provide input shape as well. So we have provided input underscore shape is equal to 784. Can you see this one? Otherwise, the output of the previous layer will be used as the input of the next layer. Okay, and what is this input underscore shape? Input underscore shape represent the shape of input data. Okay, what does it represent? It represent the shape of input data. Got the point? Yes. So here, what we have done here, we have added the input layer. So we define the input layer, which is the first layer in our network, using the following statement: model.add dense 512 comma input underscore shape is equal to 784. So this statement is going to create a layer with 512 nodes or the neurons with 784 input nodes that you can see in this image. Yeah. So in this statement, dense is an entry level layer which is provided by the Keras, which accept the number of neurons or the units as its required parameter. And if the layer is the first layer, then we need to provide the input shape as well. Otherwise, the output of the previous layer will be used as the input of the next layer. Got the point? Yeah. And then what is the next thing here? Input underscore shape. So here input underscore shape represent the shape of input data. So what is our shape? Input vector 784. Can you see this one? Yeah. 784 input nodes. Yeah. Now, before going to proceed further with the sequential model, I want to give you more detail. I want to explain you more detail about input shape. Okay. Now, before that, let's execute all this code that we have seen till now. What we have seen first of all? First of all, we have written from keras.models import sequential. Am I right? And then we have used sequential function. Model is equal to sequential. Am I right? And then what we have done? we started with adding the layers to our network. So what layers we have added till now? We have added the first layer, input layer, with the help of this statement that you can see here in a red color. Yeah, got it? Okay, now and also before going to add the layers, you need to make sure that you have imported some packages. Which packages? Dense, dropout, and activation from keras.layers. Okay, so from keras.layers, import dense, activation, dropout. Okay, so let's execute all this code till now, whatever we have seen. So yeah, let me open the Jupyter notebook. See here, it's executed now. Let me run it again in front of you. See here, it's running. So it's executed successfully. From keras.model, import sequential, and then sequential function is equal to models. Yeah, it's run. Let me run this again. Here, can you see that it's run successfully? And then sequential. So sequential function we have used here. Now, before going to add the layers, you need to import dense, activation, dropout these packages from keras.layers. So see, from keras.layers, import dense, activation, dropout. So see here, let me run this code. So it's run successfully. Can you see this one? 12. And then to add the input layer to our network, we need to execute this statement. Model.add dense 512 input underscore shape is equal to 784. Let me run this code. So it's running. Just wait. Yeah, it's run successfully. Can you see this one? 13. Okay. So till now, I hope you understand how you can add the input layer. Yeah, am I right? So it's very easy. What we are learning here currently, we are focusing on what we are focusing. We are focusing on Keras model. So the Keras models can be created in a with three different ways. First one is with the help of sequential model. Second one is functional API, and the third one is this one, subclass model subclassing. Okay, so we started with the sequential model. Okay, so for a sequential model, first of all, we have imported sequential from keras.model. So like this one, from keras.model, import sequential. So our neural network model consists of a linear stack of layers. So in order to define such a model, we need to call the sequential function like this one. Model is equal to sequential. And then next we need to add the layers. So now we will be defining our deep learning neural network using the Keras packages. So we need to import the packages such as dense, dropout, activation package for defining the network architecture. So for that, in order to import these packages, you need to write from keras.layers, import dense, activation, dropout. And then once you're done with it, you can start adding the input layer. So to add the layer, we need to simply create a layer using Keras layer API and then pass the layer through the add function. So like this one, model.add dense 512 input underscore shape is equal to 784. So here, what is this dense? Dense is an entry level layer provided by the Keras which accept the number of neuron or units as it required parameter. If the layer is the first layer, then we need to provide the input shape. Okay, and then what is this input underscore shape? It represents the shape of the input data. Okay, so till now we have executed this code. The first one is this one. Yeah, and then this one. Okay, and then this one. Yeah, now before going to proceed, let me explain you what is actually the input shape. So see here. To create the first layer of the model or input layer of the model, shape of the input data should be specified. Okay, so to create the first layer of the model or the input layer of the model, the shape of the input data should be specified. So in machine learning, all type of the input data like text, images or videos will be first converted into the arrays of numbers and then feed into the algorithm. Input numbers may be the single dimensional array, two dimensional array or multi-dimensional array. So we can specify the dimensional information using shape, a tuple of integer. For example, can you see this one 4, 2? What does it represent? It represents the matrix with 4 rows and 2 columns. Okay. So let's suppose, so just want to show you how can you write the program for the input shape in a simple way using the Python concept. So just write import numpy as np, shape is equal to 4, 2. And then input is equal to numpy.0 shape print input. What does it going to create? Tell me. By the way, I hope you know the concept of numpy, okay, which is very important. Yeah. So what is this shape? Actually, 4, 2 represent a matrix with 4 rows and 2 columns. So it is going to have a matrix with 4 rows and 2 columns. What I'm doing with the help of numpy.zeros, I'm passing the shape here. So this means it is going to create, yeah, a matrix with 4 rows and 2 columns. And all the values of this are 0 because I'm writing numpy at 0. So let me show you this one. Let me just execute this code in front of you. So see here. Let me run this code. Can you see this one? Import numpy as np, shape is equal to 4, 2. What does it represent? It represents a matrix with 4 rows and 2 columns. And then I will write numpy.zeros shape. What is my shape? 4, 2. So 4, 2 means 4 rows and 2 columns. So I am going to have a matrix with 4 rows and 2 columns. And all the values for this one is 0 because I'm writing numpy.0. And the result of this one I'm storing to the variable input and then print the input. So can you see this one? Yeah. 0 0.0, 0 0.0, 0 point. This is the first row, second row, third row, fourth row, and 2 columns. Can you see this one? Yeah, got it? So in the same way, similarly, 3, 4, 2. It represents 3-dimensional matrix having 3 collection of 4 by 2 matrix. What does it represent? It represents 3-dimensional matrix having 3 collection of 4 by 2 matrix. 4 by 2 matrix means 4 rows and 2 columns. So let me show you this code, okay, by executing it. Let's execute this code. So see here. At this time, I'm defining shape is equal to 3, 4, 2. Okay, so what does it represent? It represents 3-dimensional matrix having 3 collection of 4 by 2 matrix. 4 rows and 2 columns. So see here. numpy.0 shape, the result of this one I'm assigning to the input and then print input. Let me run this code in front of you. Can you see that one? It's run. It's currently 3 here. Let me run it. It will become 4. Can you see this one? It become 4. So see here, it represents 3-dimensional matrix with 3 collection of 4 by 2 matrix. So 4 rows and 2 columns. So see here, 4 rows. Yeah, 1, 2, 3, 4. 4 rows, 2 columns. This is also 4 rows, 2 columns, 4 rows, 2 columns. So there are 3 matrices are there with 4 by 2, 4 rows and 2 columns. Got the point? Yeah, so I hope you understand what is the input shape. Okay, so to create the first layer of the model or the input layer of the model, shape of the input data should be specified. So in machine learning, all type of input data like the text, images or video will be first converted into array of numbers and then feed into the algorithm. Input numbers may be single dimensional array, 2-dimensional array or a multi-dimensional array. So we can specify the dimensional information using shape, a tuple of integers. So for example, like this one, 4, 2, that represent a matrix with 4 rows and 2 columns. So like this one. So input numpy is np. So write shape is equal to 4, 2. So it is going to represent 4 rows and 2 columns. So I will write numpy.0 so that it is going to put the values as zeros. Okay, so numpy.0 of shape. So what is my shape? 4 rows and 2 columns. So see here, 4 rows and 2 columns with all the values 0. Okay, got it? And what is this? If you write 3, 4, 2, so it represents 3-dimensional matrix with the 3 collection of 4 by 2 matrix. So see here, there are 3 collection with 4 by 2 matrix. So 4 rows and 2 columns, 4 rows, 2 columns, 4 rows, 2 columns. Got it? 3 collection, 1, 2, 3. Okay. Yeah, so now let's continue with our sequential model. Okay, so what we have done till now? Till now, what we have done? From Keras.model, import sequential. And then to add the layer, what we have done? We have used the sequential function. Model is equal to sequential. Our neural network our neural networks will have a linear stack of layers. Okay, so to define such a model, we need to call the sequential function. Model is equal to sequential. Okay, after that, what we need to do? We need to add the layers. So in order to add the layers, we need to import some packages from keras.layers. So right, from keras.layers, import dense activation dropout. And then to add the layers, the first layer, that is input layer, what we have done? We have returned the code like this one, model.add dense find the 12 comma input underscore shape is equal to 784. Okay, like this one. And then I have shown you what is mean by dense and what is the input underscore shape. Yes. Now, after adding the input layer, next we need to add the activation function for the output layer of the layer 1. Okay, once we add the input layer. Okay, so we done with that. Next, we need to add the activation function for the output of layer 1. Okay, for the output of the layer 1. So we need to add the activation function for the output of layer 1. So for that, we are going to use RELU, that is rectified linear unit, as our activation. Okay, the activation function is added using the following program statement. So right, model.add activation, and then inside a parenthesis, inside a single quote, write RELU. So you might think, what is this activation? So after adding the input layer, we need to add the activation function for the output of the layer 1. What is the layer 1? How does it look like? See here. Can you see this one? Layer 1 with 512 nodes. Yeah. So what we need to do after adding the input layer, we need to add the activation function for the output of the layer 1. So we will use the rectified linear unit as our activation. The activation function is added using the following program statement. So model.add activation of ReLU. So here you might think, what is the activation? So see, in machine learning, activation function is a special function used to find whether a specific neuron is activated or not. In machine learning, activation function is a special function used to find whether a specific neuron is activated or not. So basically, the activation function does a non-linear transformation of input data and thus enable the neuron to learn better. Output of the neuron depends on the activation function. So output of the neuron is based on the activation function. So as you recall the concept of single perceptron, the output of the perceptron neuron is simply the result of the activation function, which accepts the summation of all the input multiplied with its corresponding weight plus overall bias, if any available. So like this one, result is equal to activation of sum of input multiplied by weight plus bias. So the activation function plays an important role in a successful learning of the model. Keras provide a lot of activation function in the activation module. Okay. So for your information, the neural network works the same way as the perceptron. So if you want to know how the neural network works, learn how the perceptron works. So see here, you have the input with x1, x2, x3 with the weight. Yeah, W0, W1, W2, W3. Okay. So how does it work? Let me show you how does the perceptron works for your kind information. Okay. So you might think, what is a perceptron? So see, a perceptron is a neural network unit, an artificial neuron that does certain computation to detect feature or business intelligence in the input data. Okay. Now let's see, how does the perceptron work? So see, the process begins by taking all the input values and multiplying them by their weights. So what are all the input value here? So you have the input values x1, x2, x3. You need to multiply all the input value with the weights. Okay. The process begins by taking all the input values and multiplying them by their weights. And then all of these multiplied values are added together to create the weighted sum. The weighted sum is then applied to the activation function, producing the perceptron's unit output. Got the point? Okay. So once you add the input layer, the next thing is you need to add the activation function for the output of the layer 1. So for that, you need to use the rectified linear unit activation function. Okay. So here we are using the rectified linear unit activation function, but there are many different activation functions are available. It's up to you, but we are using here rectified linear unit function. So we will use RELU as our activation. So the activation function is added using the following program statement. So model.add activation relu. So what is the activation? In machine learning, activation function is a special function used to find out whether a specific neuron is activated or not. So basically the activation function does a non-linear transformation of input data and thus enable the neurons to learn the better. So output of neuron depends on the activation function. So as you recall the concept of single perceptron. Now at this point you might think what is a perceptron? So hence I have shown you what is a perceptron here. A perceptron is a neural network unit, an artificial neuron that does certain computation to detect features or business intelligence in the input data. Okay. So as you recall the concept of single perceptron, the output of the perceptron or neuron is simply the result of the activation function, which accept the summation of all the inputs multiplied with its corresponding weight plus overall bias if available. So input multiplied by weight plus bias if it is available. So sum of input multiplied by weight plus bias. Okay, so you're applying activation function like this one. So the result is equal to activation of sum of input into weight plus bias. So the activation function plays a very important role in the successful learning of the model. So Keras provide a lot of activation function in the activation model. So you might think, what is this perceptron? So for your information, neural network works the same way as the perceptron. So if you want to know how the neural network works, learn how perceptron works. So by the way, again, I would like to tell you that if you don't know much more about the neural network, about the perceptron, okay, and if you don't know much more about the deep learning, what are the deep learning models or the networks, then I would recommend you to learn the course which we have created, especially for the beginners. Okay, the course name is Deep Learning Foundation. So once you understand, once you complete that course, it's very easy to learn deep learning with Keras. Okay, so but for your understanding, I have shown you how does the perceptron works. So the process begin by taking all the input values and multiplying them by their weight. So if you have the input value x1, x2, x3 with their weight, w1, w2, w3. So you need to multiply inputs with their corresponding weights. Okay. And then you need to, all of these multiplied value, you need to add it together. You need to add all these multiplied value together to create the weighted sum. The weighted sum is then applied to the activation function, producing the perceptron's output. Got the point? So in short, you remember, once you added the input layer, you need to add the activation function for the output of the layer 1. For the output of the layer 1. So for that, we are using the rectified linear unit as our function. So how to add the activation function? It's very easy. Just write model.add activation and inside the parentheses write rectified linear unit. Okay. Okay. Now, once you add the activation function, next thing is, here we have applied rectified linear unit activation function, RELU. So it is most widely used activation function since it is used in almost all the convolution neural network or deep learning. The rectified linear activation function, or RELU for short, is a piecewise linear function that will output the input directly if it is positive. Otherwise, it will output 0. What does it do? The rectified linear activation function or linear unit, rectified linear unit. Okay, RELU for short is a piecewise linear function that will output the input directly if it is positive. Otherwise, it will output 0. It has become the default activation function for many types of neural network because a model that uses it is easier to train and often achieves the better performance. So in short, you can say in order to achieve the better performance of your model, okay, you can use the rectified linear unit activation function. Okay, so it has become RELU become the default activation function for the many types of neural network because a model that uses it is easier to train and often achieves the better performance. Okay, got it? So now let us execute the code. See here. Once you add the input layer, the next thing is you need to add the activation layer for the output of the layer 1. So see how to add the activation. What the activation function we are using here? Rectified linear unit. So model.add activation RELU. Let me run this code in front of you. Can you see this one? It will become 14. If I run it again, it will become 15. So can you see this one? Got it? And why we are using the RELU? Yeah, tell me. Because it has become the default activation function for many types of neural network. Okay. A model that uses RELU is easier to train and often achieves the better performance. Okay. Now next, we add the dropout of 20% using the statement below. So right, model.add dropout 20% means 0.2. What is this dropout? Dropout is a technique used to prevent model from overfitting. Okay. So you just write model.add dropout 0.2. So at this point, our input layer is fully defined. You're done with the input layer, the first layer. So next we will add the hidden layers. But as of now, what you need to do? You have added the input layer. After that, you have added the activation function. Okay. And then you have added the dropouts. We need to add the dropout of 20% using the below statement. So dropout is a technique which is used to prevent the model from overfitting. So once you execute this code, at this point, our input layer is fully defined. So let's execute this code. So see here, we're done with this one. Model.add dropout 0.2. Let me run this code. It will become 16 now. Just focus here. Yeah. So why we are using dropout? Dropout is a technique to prevent the model from overfitting. Okay, got it? So finally, at this point, we have fully defined our input layer, the first layer. Okay, got it? So what we had until now? First of all, we need to import sequential from Keras.models. So from Keras.models, import sequential, and then sequential function is equal to model. Okay. Next thing is you need to add the layers to our neural network. So in order to add the layers, you need to import some packages. So right from Keras.layers, import dense activation dropout. So you need to import these packages. And once you import these packages, then you can add the input layer or the first layer into the model with the help of add function. So model.add, inside that write dense 512 comma input underscore shape is equal to 784. And then we have seen what is dense, what is input underscore shape, and how the image look like once you add the input layer. So how does it look like? It look like this one. Yeah. This create, by the way, this code is going to create model.add dense 512 input underscore shape. It is going to create a layer with 512 nodes or neuron with 784 input node. So this is depicted in the figure, this one. Okay, a layer with 512 nodes and then the input vector is 784 pixel. After that, what we have done? Once you have added the input layer, okay, the next thing is we need to add the activation function for the output of the layer 1. Okay, once we're done with this one, we need to add the activation function for the output of the layer 1. So how we can do this one? With the help of this code. Model.add activation RELU. And then I have shown you what is the meaning of activation, what is rectified linear unit. Yes, got it? And how this activation works. Yeah. And finally, we have added the dropout to prevent the model from overfitting. Once we execute this one, so at this point, we have fully defined the input layer. Got it? So now our next point is to add the hidden layers in our neural network. Okay. So see here. So at this point, we're done with the defining of the input layer. So at this point, our input layer is fully defined. Next, we need to add the hidden layer. So see here, hidden layer. Our hidden layers will consist of 512 nodes. The input to the hidden layers comes from our previously defined input layer. Are you getting the point? Our hidden layer will consist of 512 nodes. Why? Because we have defined the input layer with 512 nodes. Yeah. So our hidden layer will consist of 512 nodes. The input to the hidden layer comes from our previously defined input layer. All the nodes are fully connected as in the earlier case. The output of the hidden layer will go to the next layer in the network, which is going to be our final and output layer. So again, we will use the same rectified linear unit function, activation function, ReLU function, and then as for the previous layer and a dropout of 20%. So we are going to use the same ReLU activation as for the previous layer and a dropout of 20%. So see here, the code for adding this layer is given here. So the same way you need to add the hidden layer. So first of all, in order to add the hidden layer, so you need to use the add function. So model.add, and then inside that you need to write dense 512. So since this is the hidden layer, so you don't need to pass the input shape here. For the first layer, for the first input layer, you need to pass the input underscore shape parameter. Okay, because it's a first layer. But in case of a hidden layer, you don't need to pass this parameter, input underscore shape. So for adding the hidden layer in our networks, it's very easy. Model.add dense 512, that is our neuron or node. Once you added then you need to add the activation function, okay, to produce the output for the layer 2, okay, for this layer. So model.add activation ReLU and then dropout. Model.add dropout 0.2. What is the purpose of dropout? To prevent the model from overfitting. Okay, or else you can also write the same code like this one. Model.add dense of 512, comma activation is equal to ReLU, and then model.add dropout 0.2. So let's execute this code. So now, what is this code? This code show you adding the hidden layers. Model.add dense 512. So once you add the hidden layer, the next thing is you need to add the activation function for this one, and then adding the dropout. So let me run this code. See here, it's executed successfully. Okay, even you can write like this one, model.add dense 512, comma activation is equal to ReLU, and then model.add 0.2. So even if you write like this one, okay, so there is no such error. You can also do this like this. Okay, now next thing, let's see. You have added the input layer, you have added the hidden layer. Now let's see what is the next thing. At this point, after adding the hidden layers to our neural network, the network at this stage can be visualized as follows. Can you see this one? So the input vector with 784 pixel. So while defining the input layer, we have defined 512 nodes. Yeah. So 512 nodes with the input shape of 784. So see here the layer 1. And then we have added the hidden layer with 512 nodes. Can you see this one? Yeah. So once you added the hidden layers by using this line of code, so at this point, our network can be visualized as follows. Can you see this one? Okay, so the input vector with 784 pixels, and then the layer 1 with 512 nodes, layer 2 with 512 nodes. Okay, the input layer and the hidden layer. Okay, now let's see the next thing. Next, we will add the final layer to our network, which is the output layer. So we done with the input layer, the first layer, and then we have added the hidden layer. Now we need to add the final layer to our network, which is the output layer. Okay, so note that you may add any number of hidden layers using the code similar to the one which I have used here. Okay, so you might think you have added, as this code say, you can see this one. This code is going to add one hidden layer. Okay, you might think, is it necessary to add only one hidden layer? So no, it's up to you. You can add more hidden layers. Okay. So note that you may add any number of hidden layers using the code similar to the one which I have used. Which code? This one. You can add more hidden layers like this one using the code. Okay. Once you're done with the hidden layers, once you added the hidden layers, next thing is you need to add the final layer to your network. That is the output layer. Okay. So output layer. So if we want to classify the output in 10 distinct units, then to add this layer, use the following statement. So model.add dense of 10. Got it? So this means if you want to classify the output in 10 distinct units. Okay, so you may have, for example, if you have the large data set, okay, that contain 10 different items. Okay, so whatever it is, or you have 10 different fruits. Okay, you have the data set with different kinds of fruit. Okay, so, and let's suppose if you would like to classify the output in 10 distinct units. So at that time, it's up to you. It's not necessary that you should have 10 distinct units. Okay, it is based on the problem. So in short, if you want to classify the output in 10 distinct units, then to add the final layer, the output layer, you need to use this statement. Which one? Model.add dense 10. So what is this 10 here? 10 here indicate 10 distinct units. So if you want to classify the output in 10 different units, if you would like to classify the output in 10 different units, then to add this layer, you need to use this code. So model.add dense 10. Got it? So let's execute this one. Okay. So see here, model.add dense 10. Let me execute it. So it will become 19. Can you see this one? What is this 10 here? If you would like to classify the output in 10 different units, then you can add here 10. If you want to classify your output in 5 different units, then you can write 5 here. Okay. Are you getting the point? So if you want to classify the output in 10 distinct units, then you can use here 10. But if you want to classify the output in 5 distinct units, you can write here 5. It's up to you. Okay. Now next thing, let's see that. By the way, we have executed this code. It's 19. Let me run it again. So it become 20. Can you see this one? Now next thing is you have added the output layer. Now next thing is, again, as we want to classify the output in 10 distinct units, we are going to use the softmax activation function. So once you added the layer, you need to add the activation function. So as we want to classify the output in 10 distinct units, we are going to use the softmax function. So in case of rectified linear unit, the output is a binary. Okay. In case of a rectified linear unit, the output is binary. For example, if you want to classify the output in 2 distinct units, for example, yes or no. Okay. At that time, you can use the activation function RELU, rectified linear unit. But in our case, since we want to classify the output in 10 distinct units, so we are going to use the activation function softmax. In case of a rectified linear unit, the output is binary. Okay. So how to add the activation function? So it's very easy. Again, write model.add activation and then supply the function name softmax. So at this point, our network model is fully defined and our network can be visualized as shown below in the diagram. Got it? So see here, the layer 1 input vector with 784, that is we created with the input underscore shape, and then the layer in which we specified 512 nodes, and then the layer 2, that is the hidden layers, 512 nodes, and finally our output layer. So our output layer contain 10 different categories, 10 different or distinct units. Okay, since our model want to predict or want to classify the output in 10 distinct units. So for that, we have used the activation function softmax. So as we want to classify the output in 10 distinct units, we have used the softmax. Yeah, we have used the softmax activation. So in case of rectified linear unit, the output is binary. So if you want to classify the output only in 2 distinct units, for example, yes, no, okay. In that situation, you can use rectified linear unit. But as we want to classify the output in 10 distinct units, we have used here softmax function, softmax activation function. So how to add the activation function? It's very easy. Model.add activation softmax. Once you added it, at this point, our network model is fully defined and our network can be visualized as shown below in the diagram. Can you see this one? The sequential model, input vector 784 pixel, layer 1. Okay, the input layer with 512 nodes, the layer 2, the hidden layer, and then the output layer with 10 different categories or 10 distinct units. Okay, got it? Okay, so a simple sequential model is as follows. So got it? So you can write a simple sequential model like with the help of this code also. Okay, so I have explained you each of these code in detail. So you might think, is it difficult to create a sequential model? No, it's not difficult to create a sequential model. Can you see this one? In using just few lines of code, you can see here, you can easily create the sequential model. So see here. Okay, once you're done, so let me execute this code. At this point, model.add activation softmax. We have done with the, at this point, our network model is fully defined and our network can be visualized as shown in the below diagram. So after executing this code, our network model is fully defined. Okay, and the overall code for this one you can see here. So see here, the simple sequential model from Keras.model import sequential. Okay, so that we can use the sequential function, and then from Keras.less import dense activation dropout, so that we can use this one, dense activation dropout. Okay, packages. So the first thing is you need to use the sequential function. The result of this one you are assigning to the model, and then to add the layers to your model. The first layer you are adding is the input layer. So model.add dense 512 nodes on neuron with input underscore shape 784. Okay, the input shape 784. Okay, comma activation is equal to rectified linear unit. You can also pass here this parameter. Okay, so once you add the input layer, the next thing is you need to add the activation function to get the output of the first layer. So you write activation is equal to rectified linear unit. And then once you're done with this one, okay, you need to add the dropout so that you can prevent your model from overfitting. And then even if you don't write it here, so it's up to you. The next thing is you need to add the hidden layers. So how to add the hidden layers? Again, the same thing, the same. Okay, model.add dense 512. Here at this time you don't need to use this one. Why? Because it's a hidden layer, it's not a first layer. Since this is my first layer, at that time I'm going to use input underscore shape, this parameter, for a first layer. But this is a hidden layer, so you don't need to use this one. So right, activation is equal to relu. So it is going to add the hidden layer. And finally, you need to add the output layer. How to add the output layer? Model.add dense 10. So what is this 10? 10 indicate that if you would like to classify the output in 10 distinct unit. So if you want to classify the output in 10 distinct unit, you just write model.add dense 10. And then you can add the activation for it with softmax like this one. Model.add activation softmax. Okay. And finally, at this point, your network is fully defined. Your sequential model is fully defined. Okay. So at this point, our network model is fully defined. Got it? Yeah, is it easy? So you can count it, how many lines of code I have written it. Yeah. Is it easy? Tell me. So don't think so much. Okay, actually, for your understanding, I have explained you each and every concept in more detail. But building a sequential model, it's very easy. Just you can focus here in a few lines of code, you can create a sequential model. Okay. But to explain you in a deep manner, I need to explain you in a brief way with the image also, so that you will understand how the sequential model can be built step by step. So I have shown you, I explained you how you can build a sequential model, Keras sequential model successfully step by step. Yes. So what are the steps we have done? So the first thing is to build a sequential model. What we have done? Tell me. So an artificial neural network model can be created simply by calling the sequential API as it's said below. So from keras.model import sequential, and then our neural network model will consist of a linear stack of layers. So to define such a model, we need to call the sequential function. So model is equal to sequential. Then we need to start adding the layers. So before going to add the layers, make sure you have imported some important packages such as dens, dropout, and activation function from keras.layers. So right from keras.layers, import dens, activation, and dropout. And then we started with adding the input layer. So how to add the input layer? With the help of add function model.add dens 512 comma input underscore shape 784. So here with the help of this code, with the help of this statement, you can say that this statement is going to create a layer with 512 nodes, a neuron with 784 input node. And you can see, you can visualize this one like this. Okay, the sequential model after adding the input layer. And then I explain you what is dense, what is input underscore shape. Yeah. As it is said that if the layer is the first layer, then we need to provide the input shape. Otherwise, you don't need to provide. So we have provided here input shape. So it is going to create 512 nodes with 784 input nodes. Okay. After that, once we add the input layer, the first layer, we have added the hidden layer. Okay. But before going to add the hidden layer, what we have done? We have added the input layer. After that, we have used the activation function. We need to add the activation function for the output of the layer 1. So for that, we have used the rectified linear unit function. So how to add the activation function? It's very easy. Model.add activation RELU. And then we have added the dropout so that we can prevent our model from overfitting. Okay. Yeah. And then next thing is, I have shown you why we are using the rectified linear unit here. Once we done with adding the dropout for the input layer, at this point, our input layer is fully defined. Next thing is we have added the hidden layer. So for adding the hidden layer, what we have done? We have used the same thing, model.add dense find retrieval. So since this is a hidden layer, this is not the first layer, so we don't need to pass the input underscore shape parameter. Okay, once you add the hidden layer, next thing is obviously you need to add the activation function. So model.add activation rectified linear unit, and then you can add the dropout for preventing the model, okay, for overfitting. Okay, so to prevent the model from overfitting, you can use dropout technique. Dropout is a technique used to prevent the model from the overfitting. Then once you done the hidden layer, once you added the hidden layer, the next thing is you need to add the final layer, okay, the output layer. Okay, so how to add the output layer? The same syntax you're using here, model.add dense 10. So what is this 10? If you would like to classify the output in 10 different unit, 10 distinct unit, then to add this layer, you need to use this statement model.add dense 10. Once you added it, again you need to use the activation function. So since we want to classify the output in 10 distinct units, so we have used here softmax activation function like this one, model.add activation softmax. So at this point, our network model is fully defined and our network can be visualized as shown here. Yes. Input vector 784 pixels, layer 1, 512 nodes, layer 2, 512 nodes, and then output layer 10 different categories. Okay. And finally, the overall code for building the network, for building the sequential model is, you can see here. So from keras.model import sequential, from keras.layers import dense activation, or you can also add the dropout here. Okay. And then model is equal to sequential. Yeah, so you want to create sequential model. So model.add, adding the input layer. Okay, and then once you add the input layer, you need to add the activation for it. Okay, and then this one, adding the hidden layer, adding the activation, and then adding the output layer, the final layer. Got it? Yes? Yeah, got it? By the way, we are going to add the activation function for the output of the layer 1. The previous layer, you can say that. So in case of the hidden layer, see here. Once we added the input layer, okay, once we add the input layer with 512 nodes, with 784 input nodes, what we have done, we have added the activation function. Yes, we have added the activation function for the output of the layer 1, for the output of the layer 1. So for that, we have used rectified linear unit as the activation function. Yeah, got it. So in short, what you can say, in order to add the layers, so you just write like this one, model.add. So dense 512, number of nodes, comma input underscore shape is equal to 784, comma activation is equal to rectified linear unit. So it is going to represent the first input layer with the activation function. The second one, it is represent the hidden layer with the activation function, and this one, it represent the final layer or the output layer with 10 different units, or you can say, in which we are classifying the output in 10 different categories. Got it? Yes. Even you can also write the simple sequential model as follows. So for example, like this one, you have sequential model like this: from keras.model import sequential, from keras.layers import dense comma activation. Model is equal to sequential model.add dense of 512. Activation is equal to rectified linear unit, comma input underscore shape 784, in which we are adding 512 nodes with the input 784. Okay, activation rectified linear unit. Okay, got it. And by the way, here, if I'm not adding the dropout, the comma should not be here. Okay, so got it. Yeah, so we have executed this code in front of you. Let me again execute it again, so there is no error. Got it. So how you can build a simple sequential model? Got it. A simple sequential model is as follows: is created using the following code. Got it. Now next thing is access the model. But before going to explain this, I hope now you understand the sequential model. Okay, so I hope you understand each and everything in detail. Okay, so I have shown you how you can develop, how you can build the sequential model step by step. Yes, got it? Yeah. So I hope you understand what were the topics we have covered. So we have seen what is the Keras model, what are the different ways to create the Keras model. The first one is sequential model, second one is the functional API, and then model classing. Okay, so we started with the sequential model. So I have shown you how you can create, how you can build the sequential model, Keras sequential model step by step. Yeah, we have seen the theory about it, and then we have executed the code for it to build a sequential model successfully. Got it? So the next thing is accessing the model. So I will continue with that point in the next session. But as of now, I hope you understand each and every point, each and every concept that is required for building the sequential model. Got it? And I hope you understand how you can add the input layer, how to add the hidden layer, how to add the output layer, what is the role of activation function, what is the role of dropout, yeah, and how the sequential model look like after adding the input layer, after adding the hidden layer, after adding the output layer, the final layer. Yeah, got it. So I will continue with the next point of accessing the model in the next session. Okay.